Happy Friday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different questions that may be, two different classes, excuse me, that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu. and I'll respond as soon as I can. So today, eventually, we're going to go on and cover section 7.5, but first we have some questions. All right. This first one is from section 7.3, number 28, and it says, build the following rational expression into an equivalent expression with the given denominator. So we have 5 over r is the original rational expression, and the new denominator is 30r. So what we want to do is we want to take 5 over r and rewrite it as something over 30r. So the question is, what do we need to multiply the denominator by to turn r into 30r? The answer is 30. But if we're going to multiply the bottom of a fraction by 30, we must also multiply the top or the numerator of a fraction by 30. So our new numerator is 150, and our final fraction answer is 150 over 30r. Any questions on that problem? All right. This one wasn't requested, but I'm going to do it anyway. It's right after that. It's number 29. Same idea. It says build the following rational expression into an equivalent expression with a given denominator. The original rational expression or fraction is 8 over 5b. The new denominator is 5b to the 5th power. So basically we want to take 8 over 5b and rewrite it as a new equivalent fraction with a denominator of 10, 5 to the 5th power. So what do I have to multiply 5b by to get 10b to the 5th? Well, it would be 2b to the 4th. That would give me 10b to the 5th. Since I multiplied the denominator by 2b to the 4th, I have to multiply the numerator by 2b to the 4th. So the new numerator becomes 16b to the 4th, and our final fraction is 16b to the 4th over 10b to the 5th. Any questions about that one? All righty. We're going to take a look at some other ones here. Let's see. This is going to take us back. We've got some questions from 7.1, 7.2, and 7.3. Okay, let's see here. All right, so this is section 7.1, number 15. It says, simplify, assume that the denominator is not 0. We have the following fraction. 2 times the quantity, t minus 1, plus 2, all over 2t plus 2. First of all, we need to simplify the numerator by distributing. We get 2t minus 2 plus 2 over 2t plus 2. In the numerator, combining like terms, the minus 2 and the plus 2 would cancel out. So now I've got 2t over 2t plus 2. However, I can take the denominator and factor a 2 out of it. So now my factors of the numerator are 2 and t. My factors of the denominator are 2 and the quantity t plus 1. I can reduce out the 2 over 2, and my final answer is t over t plus 1. I can't cross out the t's because the t in the denominator is not a factor. It's part of the entire factor t plus 1. So that takes us back a ways. Any questions about that problem? Okay. Let's see, we've got some questions from 7.2. Let's see here. So this is 7.2, number 11. It says multiply and then simplify if possible. This is a good review of all the sections we've covered so far. Multiply and then simplify if possible. So we have p squared minus p minus 6 all over 5p minus 15 times 4p squared minus 11p minus 3 over p squared minus 3p. So the first thing I need to do is factor everything. So this first trinomial on the left numerator, we're going to have a p and a p and a minus 3 and a plus 2. That would give us minus 6 at the end and minus p in the middle. Let's see here. So now we've done that one. Let's take a look at this one. We can factor out a 5 and have p minus 3. Okay. I'm going to do this one next. I'm going to save the hardest one for last. Here we can factor out a p and have a p minus 3. Okay, let's see if that's right. P minus 3. Okay, so now what I've got left is this one. I'm going to take that and recopy it on the next page. Let's see, 4 negative 11 negative 3. 4p squared minus 11p minus 3. So here we have a trinomial. It's in standard form. There's no greatest common factor. It's not a perfect square. It doesn't have a leading coefficient of a 1. So I'm going to use grouping. A is 4, B is negative 11, C is negative 3. The product is negative 12. The sum is negative 11. The numbers are negative 12 and 1. So we get 4p squared minus 12p plus 1p minus 3. Factoring by grouping. The greatest common factor of the first two terms are 4p. I get p minus 3 left over, and p minus 3 left over on the right with a plus 1 outside. So p minus 3, 4p plus 1. So now I'm going to take that and go back to the previous page. P minus 3, 4p plus 1. P minus 3, 4p plus 1. Okay. Now I can reduce out the common factors. I can get rid of what, a p minus 3 and a p minus 3, a p minus 3 and a p minus 3. And let's see, what do I have left? I have p plus 2 times 4p plus 1 over 5p. And there is the final answer on that one. Any questions about that one? Okay. Let's see here. Coming up next, this is 7.2, number 29. It says, perform the operation and simplify if possible. This time we're starting out with dividing. We have b squared minus 5b plus 6 over b squared minus 10b plus 16 divided by b squared plus 2b over b squared minus 6b minus 16. Now, the first thing I'm going to do is recopy the whole thing, but change it into, instead of dividing by a fraction, multiplying by its reciprocal. So I'm going to have b squared minus 5b plus 6, that's a 6, over b squared minus 10b plus 16 times b squared minus 6b minus 16 over b squared plus 2b. Hopefully I won't get my b's and sixes mixed up. Okay, so now I'm going to factor each thing. This is going to be b and minus 3 and minus 2 to get a minus 5b and a plus 6. this is a B and a B and a -8 and a -2 to get a -10B and a +16. This is a B and a B and a -8 and a +2 to get -6B and a -16. And finally, we'll take out a B and get B times B +2. So reducing out the common factors, those reduce down to 1/1. Those reduce down to 1/1. Those reduce down to 1/1. And I have B -3/B. And I can't reduce out the B's because the B in the numerator is not a factor of the whole thing. Okay, any questions on that? All right, going on. This is still in 7.2. This is number 33, part B. It says perform the operations and simplify. Basically, pretty much like the one we just did. We're going to start out with division of fractions. So 2a -6 all over 5 divided by 5a -15 all over 2. So I'm going to rewrite division of a fraction by multiplication of its reciprocal. 2a -6 over 5 times 2 over 5a -15. Okay. Let's see, I can factor out a 2 there and I get an a -3. I can factor out a 5 here and I get an a -3. I can reduce out the common factors of a -3, and I'm left with 2 times 2 is 4 over 5 times 5 is 25. And finally, we've got a question from 7.3. Let's see here, 7.3. Come on, here we go. Okay. All right, this is 7.3, number 24. Find the least common denominator of the pair of rational expressions. B -5 over 9b plus 27 and b over 6. All right, so we're not adding or subtracting or changing one into the other. We're just finding the least common denominator. 9b plus 27 could be rewritten as 9 times b plus 3, which could be written as 3 times 3 times b plus 3, or 3 squared times b plus 3. So that's kind of the prime factorization of that first fraction. 6 is 2 times 3. So my least common denominator is the product of the highest power of each different prime factor. What are the prime factors? We've got a 2, we've got 3s, and we've got b plus 3s. So I need a 2, 3 squared, and a b plus 3. So 2 times 3 squared times b plus 3, which is 2 times 9 times b plus 3, which is 18 times b plus 3. And there is your least common denominator. All right, that takes care of all the questions that people emailed me. Before we go on, anybody else have any questions? All righty, then we'll go into section 7.5, which is simplifying complex fractions. First of all, let's clarify what the difference between a simple fraction and a complex fraction is. Here are some examples of simple fractions. 1/2, 3/4, let's see, 7/18, x plus 1 over 9. Those are all simple fractions. Before I clarify that, let's look at some examples of complex fractions. X over 7 divided by 3/4. X over 7 plus y over 2 over x plus -9. A complex fraction, or wait, hang on, let me get a couple more examples. 2x over 3 divided by 16. A complex fraction has another fraction or two or more within the bigger fraction. So for instance, here, there's a fraction in the numerator and a fraction in the denominator of the bigger fraction. So it's a complex fraction. Here we've got what? Two fractions in the numerator, one in the denominator of the bigger fraction. Here's a fraction in the numerator of the bigger fraction. So those are all complex fractions. These are all simple fractions. There's just the one fraction. The goal is to take a complex fraction and convert it into a simple fraction. And then if there's more you can do, like reduce it or whatever, you do that next. But initially, take a complex fraction and change it into a simple fraction. All right, let's take a look at an example. 2/3 divided by 3/4. If you took arithmetic way back, math 50, 75, whatever, you learned that if you have a fraction divided by a fraction like this, you can rewrite it as 2/3 divided by 3/4 and rewrite it as 2/3 times 4/3. It's reciprocal. Once you have multiplication of fractions, if you can't do any pre-reducing, you just multiply straight across. So we've taken the complex fraction, and changed it into a simple fraction. Any questions about that example? Okay, let's take a look at another example of that. Let's say we have 14 over 15m, all divided by 21 over 25m to the 6th power. Just like the previous problem, we can rewrite this as 14 over 15m divided by 21 over 25m to the 6th power. We can then rewrite it as 14 over 15m times the reciprocal, which is 25m to the 6th over 21. Now we're multiplying fractions. In this case, we can pre-reduce. The 14 over 21 can be reduced down by a 7 to give us 2/3. The 25 over 15 can be reduced by a 5 to give us 5/3. And the m to the 6th over m can be reduced down to m to the 5th over just 1. So now in the numerator, I have 2 times 5, which is 10, m to the 5th power, over 3 times 1 times 3, which is 9. And so I have 10 m to the 5th over 9. Any questions about that example? Now, this method works really great when you have a single fraction divided by a single fraction. But what if life gets a little more complicated, as it often does? Let's say we've got something like this: 1/2 plus 3/4 over 3/2 plus 1/4. Well, back in Math 50, we probably would have taught you to take the numerator and add those two fractions by getting a common denominator and go through all that, and then do the same thing to the denominator of the big fraction, and then treat it like we did the two previous problems. But there is another way that I think you'll find is quicker. And what we're going to do is this. First of all, we're going to find the least common denominator of all the little denominators. So the least common denominator of 2, 4, 2, and 4 is 4. Any questions about that? Okay, so now what we're going to do is we're going to multiply this fraction by the least common denominator over the least common denominator. And I'm going to write it like this and put those little ones in there to remind us that this 4 in the numerator is in the top of the numerator, and the 4 in the bottom denominator is in the top of the denominator, so to speak. So how does that work out in terms of our multiplication? Okay. So we're going to get 1/2 times 4 over 1 plus 3/4 times 4 over 1, which is 2 plus 3, which is 5. Okay, in the numerator. Any questions how I got those reduced and everything? All right, And then in the denominator, we're going to get 3/2 times 4/1 plus 1/4 times 4/1. 3/2 times 4/1, 4/2 is 2. So I get what? 6 plus the 4's reduce 1, which is 7. So my final answer is 5/7. I've taken a complex fraction and converted it into a simple fraction, and I can't reduce the simple fraction any more than it already is. Any questions there? All right, let's take a look at another one. Let's see, we've got 2 over x minus 1/3, all divided by 2/3 plus x over 5. So now my denominators are x, 3, 3, and 5. So what's the least common denominator of x, 3, 3, and 5? Well, it would be 3 times 5 times x. So the LCD is going to be 15x. So I'm going to multiply the top and the bottom of this complex fraction by 15x. So by 15x over 1 divided by 15x over 1. Okay. Basically, this whole thing right here is just 1, right? If you reduced it all down, and that's legal. We can multiply the top and the bottom of a fraction by 1. So now, again, we're going to distribute. So we're going to get 2 over x times 15x over 1 minus 1/3 times 15x over 1, which is going to be, let's see here, the x's would reduce down and give us what? 30 minus, and then the 15 over 3 is 5/1, which is going to be what? Minus 5x. So our new numerator simplifies down to 30 minus 5x. Okay, in the denominator, 2/3 times 15x, over 1, plus x over 5 times 15x over 1. Simplifying, 15 over 3 is 5. 2 times 5 times x, we get 5x, plus 15 over 5 is 3/1. So we get what? 3x squared. Okay. So we've turned it into a simple fraction. Now the question is, can we simplify that, reduce it any further? Well, I can factor a 5 out of the numerator and get that. I can factor an x out of the denominator and get that. However,
wouldn't that last 5x be a 10x and then you 30x and then you would
my bad. Thank you, Lindsay. I'm glad somebody's awake here. Absolutely. Absolutely. Okay. Yes, it would be a 10x. And then we'd still just take out an x, and we'd have what? 10 minus or plus 3x. Is that right?
That's what I got.
Yeah, unfortunately, we still can't do anything more with that, but thank you for correcting me there. So we'll just go back to this as our final answer. So that is a simple fraction, right? Okay, yes. So as I've often told you, and now I need to tell myself, be careful when you're crossing things out, that you know what's still there and what isn't. Okay, penmanship was never one of my forte subjects or whatever. Okay. How about this one? 3/5 minus 2 all over 2/5 minus 2. So keep in mind, there are implied ones in the denominator of those 2's, right? So our least common denominator is what? Of 5, 1, 5, and 1 is going to just be 5, right? So we're going to multiply by 5 over 5. Let's see if I can redeem myself and do this one correctly. You never know. It could happen. All right. So here I've got 3/5 times 5 over 1 minus 2 times 5 over 1. I'm going to do the whole thing. In the bottom, 2/5 times 5 over 1 minus 2 times 5 over 1. Okay. So far, so good. Reducing down, these 5s will go. And I've got 3 over 1, which is 3. And then minus 2 times 5 would be minus, oh, not minus 6, minus what? Minus 10, okay, which is -7. In the denominator, the 5's reduced down, giving me what? 2. And then minus 10, which is -8. Negative divided by negative is positive. So my final answer should be 7/8. Any questions about that? So what are the steps? Find the LCD, multiply the top by it, multiply the bottom by it, reduce everything down, simplify it. And then when you've got a final simple fraction, see if you can reduce it further. Okay, how about, let's see how we're doing for time. We got lots of time. All right. Because there's no place you'd rather be on a Friday than right here with me, right? Okay, maybe not, maybe not. I can always dream, can't I? So what do we got here? We've got 3/4 plus 1 divided by y all over 5/6 minus 1 over y. So my denominators are 4, y, 6, and y. My least common denominator is going to be 12y. Anybody need me to go through the process of how I got that? Okay. I'm going to multiply by 12y over 12y. Distributing, I'm going to get 3/4 times 12y over 1 plus 1 over y times 12y over 1. In the denominator, 5/6 times 12y over 1 minus 1 over y times 12y over 1. I'm going to come back and simplify. 12 over 4 is 3 over 1. Y over y is 1 over 1. 12 over 6 is 2 over 1. And y over y is 1 over 1. So what do I have over here? Let's see, 12 over 4 was 3 over 1. So I've got, what, 3 times 3y. So 9y, because there's a y there. Okay, I didn't miss it this time. And then plus what, 12. Okay, in the denominator, 5 times 2 is 10y minus 12. Okay, so there's a simple fraction. Now, can I reduce it further? I can factor a 3 out of the top and a 2 out of the bottom, and that gets me nowhere. So I'm going to go back and say that's my final answer. Okay. Any questions about that one? All righty. Let's take a look at another example. So basically, there's 2 ways of doing this. If you've got a single fraction over a single fraction, you can take the top divided by the bottom, the top divided by the bottom, the top times the reciprocal of the bottom, like those first ones we did. Or if it's more complicated than that, you find the least common denominator of all the fractions, multiply the top and the bottom by it, reduce, simplify, etc. Okay. How about this one? Let's see. D plus 2 over 2 divided by D over 3 minus D over 4. So my denominators are 2, 3, and 4. The least common denominator would be 12. And again, if you have any questions how I got that, please speak up and I'll go through the process. We're going to multiply by 12 over 12. Oh, this is going to be a little bit tricky. We've got D plus 2 over 2 times 12 over 1. That's all there is in the numerator, isn't there? In the denominator, we've got D over 3 times 12 over 1 minus D over 4 times 12 over 1. Okay. So now in the numerator, I can take the 12 over 2 and reduce it to a 6 over 1. Okay. Then I'm going to distribute and I'm going to get 6D plus 12. Okay. Any questions there? In the denominator, 12 over 3 is 4. So I get 4D. And 12 over 4 is 3. So minus 3D. So I've got 6D plus 12 over D. I can factor a 6 out of the numerator to get that, but the D's don't reduce out. So again, I'm just going to go back to that step. But I always want to look and see if there's something that can be reduced out. All right. Any questions there? Okay. Let's take a look at this one. 1 over x minus 1 all over 1 minus 1 over x minus 1. I know, just when you thought you'd had enough, he makes things even more complicated. So my least common denominator here is x minus 1. So I'm going to multiply by x minus 1 over x minus 1. And I'm going to distribute. I'm going to multiply here, and here, and here. So up top, I've got 1 over x minus 1 times x minus 1 over 1. That's this thing. In the bottom, I've got 1 times x minus 1 over 1. And then minus 1 over x minus 1 times x minus 1 over 1. Okay. So simplifying in the numerator, the x minus 1 is reduced down, and I have 1. In the denominator, this is just what? 1 times x minus 1 over 1 is x minus 1. And then here, those reduce down. So I've got what? Minus 1. So I end up with 1 over x minus 2. So there's my, final answer. Any questions there? Let's see here. How about this one? 1, let's go back to that. 1 plus 6 over t plus 8 over t squared all over 1 plus 1 over t minus 12 over t squared. So the least common denominator here is going to be t squared. Any questions about that? Okay. So we're going to get 1 times t squared over 1 plus 6 over t times t squared over 1 plus 8 over t squared times t squared over 1. In the denominator, we're going to get 1 times t squared over 1 plus 1 over t times t squared over 1 minus 12 over t squared times t squared over 1. Simplifying, let's see, the ones can go away and basically we've got what? T squared. And then t squared over t gives us just a t on top. So we've got plus 6t. T squared over t squared is 1 over 1, and we've got plus 8. In the denominator, the ones reduced down, well, so we've just got t squared. T squared over t is t, so we've got plus t. And then t squared over t squared is 1 over 1 minus 12. Okay. Well, let's see if we can factor that any further. In the numerator, t plus 2, t plus 4. In the denominator, let's see, we'd have t plus 4, t minus 3. I think that's right. So the t plus 4s reduce out, and our final answer is t plus 2 over t minus 3. How fun is that? Okay. One more, and then we'll set you free. 3 over a b squared plus 6 over a squared b all over 6 divided by a minus 9 divided by b squared. All right. So I've got a's and b's. My highest power of a is a squared. My highest power of b is b squared. So the LCD is a squared, b squared. Again, any questions about how I got that? All right. So we're going to multiply by a squared, by a squared b squared over a squared b squared. So distributing 3 over ab squared times a squared b squared over 1 plus 6 over a squared b times a squared b squared over 1 all over 6 over a times a squared b squared over 1 minus 9 over b squared times a squared b squared over 1. Boy, you really got to make sure you can read your own writing here. This is a 6. Okay. Let's see. A squared over a is an a on top. B squared over b is just 1 over 1. So this whole thing becomes what? 3a. Okay. And here, a squared over a squared is 1 over 1. B squared over b is b. So this whole thing becomes plus 6b. Down here, a squared over a is a. So we get 6ab squared minus, the b squareds reduce down to 1 over 1, minus 9a squared. Okay, what can we do? We can take a 3 out of the numerator and get a plus 2b. we can take a 3a out of the denominator and get b squared minus 3a, which gets us nowhere. So hang on here.
Wouldn't the b squared be 2b squared on the denominator?
Yep, I messed up again. 2b squared. Yes, it would. I'm glad that somebody's awake. I put everyone else to sleep, including myself here. Like that. So I can't reduce it any further. Or can I? Hang on a second here. Oh.
Could you reduce the 3's out of it?
Yes, I can. That's what I'm looking. Yeah, I was looking for something more complicated than that. I can take out the 3's. So then I've got, let's see here. Nah, I've got no room. A plus 2b over, and we could leave it factored, or we could put the, let's see, what do? They put it back in over 2ab squared minus 3a squared. I don't even know if you can read that. It's so small. Can you see that?
Yeah, you can see it on here.
Okay. Yeah, well, my own hieroglyphics here. All right. So find the least common denominator. Multiply the top and the bottom by the least common denominator. Reduce, simplify, reduce, simplify, reduce, simplify, and pay close attention, stay awake so that you don't make the mistakes that I make. See, fortunately, I have several people watching me, so, but you're on your own when you're doing this, I know. All right, I'll be back this afternoon at 1:15 with an office hour. Otherwise, I'll see you Monday at 11:30. Have a great weekend. Stay safe.
I have a question.
Yes.
Could you do one more problem? It seems really simple, but even after talking to you, I can't get the hang of it.
Bring it on. What do we got?
1 over y plus 3 over 1 all over 3 over y minus 4 over 1.
So like that?
Yeah.
So what's your least common denominator?
It's going to be the y, 1y.
Yeah, correct. Okay. So 1 over y times y over 1 plus 3 over 1 times y over 1. Okay. In fact, let's keep going, which is going to be 1 plus 3y, because the y's would reduce down in that product.
Oh, okay. So I was just reducing it and canceling it out all the way, but you would plus the 1.
So you were turning this into 0.
Yeah.
Yeah, which is why don't use the word canceling, because canceling implies it goes away. You're technically just reducing it or simplifying it down. Yeah.
Okay.
Yeah. And then here, what, 3 over y times y over 1 minus 4 over 1 times y over 1. Those are going to reduce down to a 3 minus 4y, and that's as far as you can go.
Okay. So it was not reducing, it was canceling.
Well, you were canceling,
Should have
should have
been
been reducing. Yeah. So like 3 plus negative 3, those cancel. 3
Right.
over 7, or 3 times 7, 4 over 3, those reduce. Because
Okay.
otherwise, let's say you had 3 times 2 over 2 times 3. If you canceled, you'd say, oh, that's 0. But it isn't, it's 1.
Yeah. And it was because it was being added, it wasn't being multiplied, or else that would have been different.
Yes. Yes.
Okay.
It's all
All right.
about the operations.
Thank
All right. You're welcome. I will go ahead and stop the recording.